This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know-How is brought to you by iFixit. You've seen their teardowns all over the internet, the free repair guide for everything, and the ultimate marketplace for electronic tools and parts. For $5 off your purchase of $10 or more, go to iFixit.com/twit and enter the code KNOWHOW at checkout. And by Harry's, for guys who want a great shave experience for a fraction of what they're paying now. Harry's is so confident in the quality of their blades, they want you to try their shave set for free. Just pay shipping. Start your free trial today at harrys.com and use the code KNOWHOW. On today's show,
you'll know how to add a real-time clock to your Growduino.
Welcome to Know-How. It's a Twitch show where we build, bend, break, and upgrade. I am Father Robert Balaser.
And I'm Brian Burnett.
And for the next 30, 40, hour, whatever, however many minutes it takes, we're going to be showing you some of the geek knowledge that we've been playing with so you can take it home and geek out on your own. Brian.
Padre.
We've done 2 weeks of Project Growduino.
That's right. Yeah, it's been a lot of fun. We've made a mess, and the biggest indication that something might go wrong is when there's a giant jug of water next to me and electronics on the table.
5 gallons and some seriously high voltage electronics. That's always a good thing, right?
All right, so I will be your Vienna White today while touching everything, right?
Yes, please. If you could do that. No, but okay, so this has been a gradual build-up. The first week, what we showed them how to do is how to create a solenoid-controlled water or fluid reservoir.
Right, which was a lot of fun to play with because you push a button and something happens, which is always great.
Precisely. And then the next week what we showed people how to do is how they could control that solenoid through a relay so you could control a higher voltage circuit with a lower voltage circuit. And of course the reason why we did that is because we wanted to be able to control it from an Arduino. Right. And Arduino could not generate the 12 volts necessary to actuate the solenoid.
Exactly.
But last week what we did was we showed how through the relay I could take the 5 volts coming out of an Arduino to activate a 12-volt circuit that would trigger the solenoid that would let the water flow.
Right, and the whole reason we wanted to use the Arduino is because we wanted to set up scheduling or like some system of monitoring when the water was being used.
Precisely. We needed to be able to use an embedded processor, and we want embedded because we want to be able to like just pull power and reconnect and have everything work.
Right.
We don't want a boot process, we don't want Linux, we want something really, really simple, something almost bulletproof, and that's why we went with an Arduino.
That's right, like most of our projects, we're following the KISS method, right? Keep it simple, stupid.
Well, I mean,
kind
not
of.
completely simple, but mostly simple.
Yeah.
No, but yeah, exactly. The simpler that we can keep it, the better it will be, especially when we're talking about a embedded controller that has control of something that could destroy my plants.
Right, which has destroyed your plants.
Actually, literally that one has destroyed my plants. Well, okay,
wow.
I say this one, but it was really this stupid brain with its coding that destroyed my plants. But so this was the project that we had last week. Very simply, it allows me to run code on this that would trigger this relay that would connect to a solenoid that would open up the water.
Right.
The thing is, though, I mean, although it was cool to be able to control with my laptop what the solenoid would do, that's not super useful.
No, because you were still standing about 3 feet away from the water.
Precisely. I could just turn the valve. What I need is I need to add some smarts. So what we want to do today is we want to show you a component that you can add. In fact, a component that you should add to many of your Arduino projects in order to give it at least some semblance of real-world utility.
Cool.
And that is called an RTC, a real-time clock.
Ah, yes. So this is the way the Arduino will be able to keep track of time.
Precisely. Now, Smitty, remember Smitty? Well, he's sort of our spirit animal. Yeah.
Oh, yes, the
guy.
soldering master.
The soldering master. The man who says you've soldered badly and you should feel bad.
Yeah, that's his motto.
Yeah,
and then
exactly.
makes people cry.
Runs away crying. But he reminded us that you can kind of keep time on an Arduino. If you look at how many cycles it's running, and then you can kind of say, well, I'll divide that to make it kind of approximate seconds. You can do that, but it's not really accurate. And more importantly, when you pull power, when you power cycle it, it loses all that. It starts from 0 again, right? The RTC is a real-time clock. And you may notice right on the back here, I've got a battery. Well, what that battery allows me to do is it allows me to keep time even when I pull power on my unit. That's incredibly useful.
It's a little watch battery.
It's a little watch battery.
Or the same battery you might see on your motherboard.
Right. I think this is what, a CR2032. It's you know, one of those really, really typical. But in order for us to understand this, what we need to do is we need to understand how we're going to connect this, because this is going to be using a new type of technology, at least for us, because we've never used it on know-how, called I2C.
Okay.
Now, I2C is a serial bus. It's a way for me to connect multiple devices to a controller using just 2 wires.
Ah, all right.
Think of it this way. When we think of our Arduino projects, what we've typically done is we've assigned different functions to different pins, right?
Right, like for our LED projects,
Right,
or
so
anything that we're sending data out on.
Digital pins 2 through 6 have been used to light up the positive lead of an LED, and then maybe pins 8 through 10 have been used to connect to buttons, right? Well, you can do that. The problem with doing that is eventually you're going to run out of pins.
Eventually, yes.
Eventually, you're going to run out of pins. And I do want to connect a lot of different sensors to my Arduino, and I want to make it relatively easy for me to connect and disconnect.
Okay.
Well, I2C is a great way to do that, because rather than assigning 1 pin for every device that I want to connect to, in fact, sometimes it could be more than 1 pin, I can use 2 wires, a clock wire and a data wire, and I can connect multiple devices, many devices, all through those same 2 wires.
Okay, but how?
Well, let's talk a little bit about that. So I2C, it was developed a while back. It was in competition with the 1-wire standard. And the 1-wire standard was a way to sort of connect the sensors with just 1 wire.
Okay.
But I2C does it with a bit more precision, because instead of just a data line, you also have a clock line, which can keep things in sync.
Okay.
And what it does is, rather than just saying, okay, on this wire is a device and that device is the only one that will be communicating with me, every device has an address. And it knows how to talk to particular addresses, because I tell it in the Arduino IDE, where is the clock located? Where is the switch located? Where is the screen located? And they can all talk through I2C.
On 1 wire.
Oh, well, 2 wires, the clock wire and the data wire.
Okay, I want to see how this works, because I'm having a tough time imagining that.
Yeah. Technically, this is known as a multi-master, multi-slave, single-ended serial bus.
Oh,
that should clear it up,
of course.
Right?
Now I get it.
Let's actually take a look at how this works. Now, the first thing we want to do is we need to know where are the I2C ports on my Arduino, and it differs from Arduino to Arduino. On an Uno, a Nano, or any of the clones, SDA, so the data pin, is going to be A4, analog 4.
Okay.
And SCL, which is the clock pin, is going to be A5.
Okay.
And actually, so you can see them right here. If you go to the overhead, this is A4, the one that's the yellow wire is connected to, and A5 is the green one.
Okay.
So those are my I2C pins.
And those are ones that you set in the software for those pins, or are those just by default?
That's automatic by default. On a Mega, so that's the larger version, SDA is pin 20, and the clock pin is, I think, pin 21. On a Leonardo, which is an older one, the SDA pin is 2, and I think the clock pin is 3. And then on the Duo, SDA is 20 and SCL is 21.
Okay, will never memorize any of those.
You don't have to.
Thank you.
Just remember, you need to know which pins to connect it to.
Okay.
All right. Now, let's actually show you how it's going to work. The first thing we need to do is we need to solder one together, because they look like this. So when I buy these, they're going to come in little bags. And actually, if you go to the link, Alex, these are really inexpensive. You can buy them for what, $260, but I bought a 10-pack for like $10. And go ahead and get yourself a 10-pack, because you're going to use a lot of these.
You're going to mess up a lot.
Real-time clocks are incredibly useful, as you're going to find out in a couple of minutes. You should have a couple in your inventory. Something that you should know, however, is that most of these, when they arrive, that battery is probably going to be dead or really close to dead. They're not the highest quality batteries that they put in there. So buy yourself a pack of fresh CR2032s or CO2025s, depending on which one yours uses.
And there's nothing more disappointing than getting your project all set up and then having the battery die halfway through it.
Well, I mean, it'll work until the first time you disconnect for like more than a couple of minutes, and then it'll die again. You're like, but I had an RTC. It's like, yeah, you had an RTC with a jank battery.
My batteries or my plants are dead. No.
Yeah. Well, I mean, as long as it's energized,
it should be okay.
It should be okay, but the problem is
As soon as you disconnect power.
if you disconnect power for more than a couple of minutes, it will die again. So just assume that the battery that came inside your clock module is dead.
Okay.
All right, so what we're going to do is we're going to go ahead and load this up on our little jib. Because I forgot my helping hands. I wanted to use this.
That's right.
This is totally, see, that's my thing. Now you're going to notice I actually have P1 and P2. I could run through this module. So I could connect, like P1 could connect to the Arduino and then P2 could connect to the next I2C device. I'm not going to do it that way because I want to show how it actually works.
Okay, so you can daisy chain basically devices? Oh, okay.
You can daisy chain, but also I'm going to show you can connect them in parallel. It's an incredibly useful bus. You'll see this. I know it's hard to wrap your arms around. It's confusing, but it'll get easier.
Everything we've done has needed a separate wire to pass data.
Yep. So on this, you can see that I've got a couple of pins. I'm going to need my ground pin. I'm going to need my, what is this? My voltage pin. So that's where I'm doing 5 volts through those 2 pins. And then I have SDA and SCL, so my data pin and my clock pin. I actually don't need the other parts. So I'm going to do this.
Gentle,
just like that. I'm going to heat up my iron. Okay, and this is
smell it already.
This is the fun part because this is where you really wish you had a third hand.
Here you go.
By the way, if you're going to do it this way, do not hold the pins that you're heating up.
Oh, because you burn.
Just a
Why does it smell
FYI.
like chicken all of a sudden?
Hold on.
At least you're holding the right end of the tip there.
There we go. Once I get the first one,
then you can let go because it's held in place. Yeah.
So what I'm going to do is I'm going to go ahead and sort of even this out. Make sure it looks right. It's not straight.
Almost.
Okay, so that's straight. So I got that first pin, it's tacked in. Now I can do the other pins.
Easy peasy.
Easy peasy lemon squeezy.
Just like that.
Yes. Remember,
actually,
folks,
you can see one of the batteries right there. That's like right what she's about to burn.
Yeah, let's see. So she's probably actually just taking that battery out so she can use it on a real-time clock.
She's gonna solder it out of the board.
She's
there.
a soldering master. Okay, that's it. So that's really how simple it is. That's the only soldering I'm gonna have to do. I've got my 4 pins so I can provide power and I can get my clock signal and my data signal out.
Cool.
All right, so let's do this to make it really super simple.
There's not a lot of ventilation in here.
No, there's not. Just remember, black is ground, orange is going to be power, this brown one is going to be my data pin, and the white one is my clock pin.
Okay.
So I'm going to go over to here, and I've already, if you go to the overhead, Alex, I've already got my power broken out. So this is a 3-volt side, this is a 5-volt side. I'm going to take my voltage from here, like so. It's 5-volt ground.
Okay.
And then I've got my clock pin is white. Oh no, my what is it? I'm sorry, I reversed that. Yeah, my clock pin is white. And what did we say for? Remember when I told you which ones were which?
Wasn't it? Oh, A3.
This is an Uno. So my clock pin is A5.
Oh.
Which is going to be right here. It's the green one. And my data pin is A4, which is that one.
Okay.
I think.
Right. And we're using the breadboard.
If not, I just swap them. That's that simple. Okay, so
there won't be blue smoke.
I'm going to go ahead and pull my laptop over here. I'm going to plug this thing in. Now, it's probably going to be zeroed out. So when I first turn this thing on, when I'm going to be receiving back is nothing. It'll get back zeros because the clock has not yet been set.
Okay.
Or I'll get blue smoke. It's going to be one of them. There we go.
Or blue LED.
Yeah. All right, I'm going to preload. Alex, if you can go ahead and switch over. I'm going to preload some of the code that I did for the first test. There we go. And yeah, keep this on full screen. Don't do the split screen. We had complaints that people were saying they can't see anything if we go split screen.
We don't need to see Padre.
There we go. There's a bunch of stuff in here. Most of it was written by Adafruit. Thank you very much for doing this, because this is what we like about Arduino. We don't have to write everything because people have helped us to write it. The first thing I'm going to do is include wire.h. That's the library, and that's built into Arduino.
Cool.
That's the library that allows me to access the I2C bus.
Right.
So you need to include that. And then define. Remember how I said every device has an address?
Right.
That's what I'm doing right here. I'm defining the DS3231 I2C address as 0 by 68.
I don't get that.
That tells my Arduino where on that bus it's going to find this device.
The 0 by 68?
Yeah, that's actually that's the address of this.
How did you find that?
It's in hexadecimal.
Oh, okay.
So yeah, so that's the address. That's the address that I'm setting.
Okay.
According to the library. Okay. So and then I also have to tell it where I'm going to have my relay pin, because remember, I'm interfacing this with the software that I wrote last week.
Right.
And then this is you can probably guess, watering hour, watering minute, watering time. I'm starting to write the code that I'm going to need to tell the Arduino when to turn on the water.
Okay.
Now the rest of this is well, it's pretty basic stuff. It's it's fun though. These are conversions, because all the data that I'm getting from my my RTC is actually going to be in bytes. So I have two functions here: one that converts decimals to binary, and one that converts binary back to decimal.
Okay.
Okay. Then in my setup, I initialized the 2-wire that turns on the I2C functionality. I set the pin that the relay is going to be connected to, and then I open up my serial port. Here is something interesting. This thing that's commented out right here, this is actually the function that was inside this library that allows me to set the clock on that RTC module.
Okay.
All right, watch. Let me go ahead and do this. I'm going to go ahead and upload this code. Maybe I'm connected to the right one. Arduino and Uno, and push it, please. There you go. Save it.
So is it pulling? Does it pull the time from the Arduino, or you just physically?
It's gonna pull the time from the RTC, from the real-time clock.
Okay.
Hold on. Actually, I'm having an issue with this. I just upgraded the IDE and it doesn't like it. Compiling, and actually, if you go to the bottom, shoot, hold on.
What's wrong?
This is an issue when I try to run multiple IDs at the same time. They're now competing for the serial port. Competition is not always good. There we go. Oh wait, no, sorry, that was demo 2. That's why I'm having that issue.
Oh, demo 2.
I know, demo 2. Why are you so silly? Here we go.
Always messing with us.
Port 4 and upload, please. There we go. So we're compiling and we're uploading and
success.
Done. Okay, good. Now let's go ahead and open up our serial monitor. And if you look at this, that's not giving us a really useful date.
No, and that's what I was wondering. How do you set it now?
Well, remember that line I told you that was commented out?
Yeah.
Okay, so let's go back to that. If you look here, and actually let me increase the size so people can actually see what we're doing. There we go. How's that, Alex?
Better.
All right. So set DS time. What I'm going to do is I'm going to uncomment this, and then I use this this format: seconds, minutes, hours, day, date, month, year.
Ah, okay, that makes sense.
So what time is it right now?
Well, it says 11:25.
So let's do 25. So that's minutes. Hours is 11. Day is day is
is that February 2nd?
No, Thursday. So that's Sunday, Monday, Tuesday, Wednesday, Thursday. That's 5.
Okay.
Date is what date is it? It's the second?
Second.
Second. Month
2
is 2, and year is 17. So I upload this once.
Okay. And now you should be receiving the correct.
Right. So let's go ahead and look at this. Hold on. Oh, I have to reinitialize that.
Interesting.
Hold on. Give it time. Give it time.
Yeah, no, I'm impressed. And so, how accurate is the clock? Will it keep its time pretty close enough, I guess?
Yes, it actually very, very well. Hold on. I must have missoldered. 1 second.
Missoldered?
I know, I do that sometimes, Brian. I'm not perfect.
Despite your best efforts.
There we go. Okay, good. Now let's upload it. 1 second, 1 second, 1 second. Give it a sec. Hold on. And there we go. Now, all right. So now we've set it properly. 11/25, 2/2/17 day week is even Thursday. Right.
Yep.
Now, the reason why it's going 0101 is because of some code that I put in here to test it. What I'm doing is I am doing a little bit of math, and I'm saying whenever I'm on an even second, turn it off, and whenever I'm on an odd second, turn it on.
Right.
If you go to the overhead shot, Alex, you can see that's so what it's doing is it's turning this relay on and off, and every time it turns it on, it's switching to the green, and every time it turns it off, it's switching to blue.
It sounds like a little metronome.
It does, right? Now let's look at the code that actually allows me to do that. So skip by all this. This is all the stuff that came in the library. This just allows me to read the time. It allows me to display the time to the serial port. It allows me to set the time. That's the function I just used. Okay. Oh, and by the way, after the first time, after you set the time, you need to comment this out, because if you leave it in there, what's going to happen is every time you turn this back on,
reset it to that.
It's going to reset it to this time. So
okay, so that's cool though. It has the memory to it saves the date and then just counts after that.
Precisely.
Okay. Cool.
Okay. So wait till that's done, and there we go. Back. But the magic happens right here. Okay. So in the loop, remember the loop is the one that it's going to continuously do as long as the device is on. The first thing it's going to do is call the display time function, which was built into the library. That's going to display the time to the serial console. That's this thing. So the reason why we can see it in the console is because of that display time function.
Cool.
The next function is the very small one that we wrote, and this is super simple. All it does is this. If we go to the actual text of the function, it's going to create holding places, that's byte, holding places for all the data it's going to receive from the real-time clock. Then it's going to invoke the function that reads from the real-time clock. That's read DS3231 time.
Yep.
It's going to read second, minute, hour, day of week, day of month, month, and year. We're only going to be using one of those. We're only using second.
Right.
Okay, for this particular one. I create a new integer called on-off. And then what I do is, this is called a modulus or a mod. It's going to divide it by 2, and it's going to give into this variable I just created, it's going to give it whatever's left over.
Okay.
So if it's even, and I divide by 2, there's nothing left.
Right.
Any even number divided by 2 is going to give you
and if
no
it's
remainder.
Odd, there'll be a remainder.
There'll be a 1. Yeah. Right? Because any odd number divided by 2, you're always going to have a remainder of 1. And then what I'll do is I'll go ahead and print out to the serial console what that number is, and then I do a digital write. So I write to that pin that the relay was connected to, and I say, send the value from the mod function. Does that make sense?
That makes sense, and that's why it's doing the on-off on every other second.
Precisely, and what I've done is, with this, I've delayed it 1,000 milliseconds, so it's checking every second. So no matter where it is in that second, even if it's a couple of microseconds this way or that way, it's going to find either an even or odd. It's going to alternate, even, odd, even, odd, even, odd, even, odd. If I were to change this value to 500, what it would do is it would do on twice, off twice, on twice, off twice, because it's still into 1 second.
So now you can set up a schedule for, like, you could change it to hour, day, week.
Precisely. Yeah. This is, I mean, we're not doing this just for giggles. We're doing this because this is the fundamentals of how I'm going to trigger events with this Arduino. If I can do it for seconds, it means I can do it for minutes. If I can do it for minutes, it means I can do it for hours. If I can do it for hours, I can do it for days, years, whatever it might be. So this is why an RTC is so valuable. It's giving me real-world information, the time, and allowing me to trigger events with that information.
Pretty cool.
Yeah, but the question is, how are we going to take this and actually turn it into something that controls the big watering system in any usable format?
How?
We're going to get to that in just a bit, but first let's go ahead and take a moment to thank the first sponsor of Know-How. Hey Brian.
What's up?
You know what I like to do?
Build RTCs for Arduinos?
And normally that means I'm going to need some pretty specialized tools.
That's true, especially if you need to take something apart
Yeah, there's nothing like using the wrong tool. We've all done it.
Yep.
Yeah, I mean, I will admit, back in the day when I needed to get something open and I was getting frustrated, it was typically get the biggest flat screwdriver I could find, jam it in the case, and just keep twisting until it pops open, right?
I was even worse. It was just whatever was in arm's reach. Anything I could find, a pen.
Yeah, but I mean, that's what we do. And we want to get the job done. We want to get in there. We want to see how it works. And sometimes we probably shouldn't do that.
No, but do it right and follow the instructions.
Precisely. Well, it's so much easier to do it right, and it's so much easier to follow the instructions when you have a place where you can go for the right instructions, and when you have a place you can go for the right tools and the right parts. That's why we're so happy to have iFixit as a sponsor of Know How. Now, iFixit isn't just a purveyor of high-quality replacement parts. They're not just a source for tools. They're not just a place where you can find thousands upon thousands of how-to and DIY manuals. They're also a community of people who understand who you are, and that is a maker. Now, this episode is brought to you by this. It's their brand new ProTech toolkit. This is gorgeous. It's beautiful. It's exactly what a maker DIYer needs. It's completely reimagined. They listened to their customers. They found out what they needed to change, what people actually wanted, and they incorporated it into this new design. It's got a durable canvas case. It's got hand-selected high-quality steel bits, a custom anodized aluminum driver handle. They've thought of everything. That means you only have to worry about the fix. This kit's going to include 64 bits, which is more than their old 54-bit driver kit, precision ESD-safe tweezers, including a pair of reverse tweezers, which, Brian, by the way, we're going to need when we get to the SMD soldering because they really help. That's the only way you can hold on to those components. A wide variety of plastic opening tools and picks to safely work on tablets and smartphones. In fact, I used those when I upgraded Leo's Surface Studio. I needed the suction cups. I needed the picks because, MAR surfaces would be horrible. Now, it's also got metal spudders and iFixit's own rubber-handed Jimmy Pride tool. It's the last precision toolkit you'll ever need, and they back it with a lifetime guarantee. Folks, the people at iFixit never stop repairing, and with this toolkit under your belt, you won't either. Head over to iFixit.com/twit and use the code KNOWHOW at checkout to save $5 on your purchase of $10 or more. Even if you don't buy anything, you can still use their free repair guides, troubleshooting answer forms, and other educational resources on their website anytime your tech has an accident. iFixit is the best way to get yourself in the DIY or maker mood, and that's why we are so proud to have them on Know How. And we thank iFixit for their support of Know How. Okay, so when we come back, we're going to have a couple of different pieces of equipment on this table because we got to get the bucket back up. We got to show how we're going to trigger it. We're going to bring together a bunch of different pieces that we've been playing with over the last couple of weeks and give you a Growduino that actually works.
Go figure, right?
I know. We don't normally like doing that on Know How.
No. Despite our best efforts, we might actually build a sweet project.
Yeah, go figure. But before we do that, let's go ahead and take a step back to the East Coast. Brian and I went over to World Maker Faire, and inside one of their tents, they had sort of all the embedded companies. You had Arduinos, you had the Beagleboard folk. And there was also one company there that gave us something that was very close to an Arduino, but was intensely modular. Something that I really like, something that I think I might even use in a future version of the Growduino.
Something that had layers.
Layers.
It has layers to it.
Layers, I know. Layers upon layers. Folks.
Like an onion.
It is the onion. The last 5 years or so has seen a remarkable quantum leap in microprocessor technology, and this Maker Faire is no exception. That's why I'm holding this. This is the new Omega 2. It's an onion product that, I think you might want to take a look at. I'm going to speak with Lazar, who's going to explain why this $5 computer might be your next step in development. Why did you develop such a small, low-cost computer?
So we were trying to make a bunch of projects for ourselves, and the existing solutions they didn't work right out of the box. So we wanted to make something that was affordable, very, very small, and that can work literally within a minute of plugging it in. So with the Omega 2, it has Wi-Fi and storage built in. As soon as you plug it in, you're ready to go. You connect it to your Wi-Fi network, and you have Linux on there. You can program in any programming language that you're familiar with, and you can make a variety of internet-connected applications. So really, we're in the IoT space. You can use the Omega 2 to control anything from, appliances in your home to robot arms to robotics using servos. So the idea is instead of, not to think of the Omega 2 as this huge, powerful computer, but just a small piece in a puzzle in your home. So you would have a variety of these, and you can control anything, like I said, from lamps to TVs. If I wanted to right now, using our Onion Cloud, I could turn on the TV and the lamps in my house back in Toronto.
This is one of these things that has been a semi-missing link in the maker community for many, many years, because too many of us will use the equivalent of laptop power to turn a light on and off. So this fits that niche very nicely. Something that, it's not super powerful. You're not going to be using this as your entertainment center, but if you wanted to automate the sprinkler system or the lighting in a particular room, this is the perfect device for it. Now, walk me through it, because I know that the module itself is just this little chip at the top, and everything else is an expansion dock. If I wanted to start developing with one of these today, how would I go about doing that?
So you would first get the Omega 2, and it's the little silver guy here. It actually plugs into, we have a series of docks. So let me just show you, oh man, I guess we don't have them right here. But anyway, the docks look like this. You plug in the Omega right here, and you can plug in any additional expansions. So we offer expansions for relays, so you would use that to control other appliances, lamps, that type of thing. We have an expansion for a small OLED screen, like this guy right here. You can display any sort of temperature sensors, any sort of sensor data you're collecting. And we also have, one of our main ones is the servo expansion used. You can control up to 16 different servos for any robotics applications. We have a variety of other ones that I can't really think of off the top of my head, GPS, Ethernet, that type of thing. So really, you just got to decide what kind of project you're going for. Order the stuff from our store. They're all plug and play. As soon as you plug in the Omega connected to Wi-Fi, the setup process literally takes 2 minutes, and you're ready to go. The real limit is your imagination.
Our audience is pretty savvy on the hardware side. They've played with everything from Raspberries to Arduinos to the BeagleBone. If they wanted to play with this, I know it's running a very small kernel of Linux. What kind of programming experience would they need? What kind of language will they program in?
So we pride ourselves on supporting as many programming languages as possible. We really want people to be able to, if you're a web developer, you can use PHP to control hardware. So we support Python, PHP, Node.js, C, and C++, just as a start. Let's see, Bash scripting. Those are the main ones that we've seen people using. I've seen people using Rust and Go as well. So the Omega is very, very flexible in that you can create things with languages that you're already comfortable with. So there's a very small learning curve.
If they wanted to find out more about the Omega 2, if they wanted to find out more about Onion, if maybe they wanted to get on the pre-order list to get one of these $5 computers, where can they go?
So we just finished our Kickstarter campaign at the end of August. We're doing another campaign on Indiegogo. So you can check out Onion Omega 2 on Indiegogo, or you can check out our website, onion.io.
Thank you very much for sharing your technology. Thank you for sharing a $5 computer. And folks, if you want to be playing with the future of Linux, the future has layers, like an onion, or parfait, or an ogre.
Ogres have layers, Padre.
You really didn't like that pun at the end, because I remember seeing you going like.
I was expecting it. I was hoping for it, and then the delivery was disappointing.
Now, here's the thing I like about that Onion, that cloud service thing. That's actually kind of cool, because I can do that with an Arduino. Remember last week I showed the Arduino, the Ethernet shield, and we have a Wi-Fi shield.
Right.
So I could connect it, I could make an interface on the board, but by definition, it's going to be a pretty lame interface. I mean, there's not a lot of power. I can't really make it look pretty. If I can use a cloud service to drive this, and if there was hooks to that cloud service that were built into it, like it is with the Onion, that might actually work kind of nicely.
Yeah, no, I like the idea of most of the horsepower being on the cloud end, and then just using the device as the hookup for the physical relay.
And that's really how it should be. I mean, this should basically be the thing that turns on or off. I shouldn't be running a web server on my Arduino. The only question I have is, is that connection going to be secure? Because
yes.
if I'm going to be internet connecting a bunch of things that can do actual things in the real world,
that's right, and come back to your plants and they're all dead because someone turned off the water.
Or they're a foot underwater because someone's like, hey, you know what? Let's turn this thing on all the way. Leave it on. That's probably not good.
Or if the cloud service isn't reliable and something goes wrong, it goes down or something like that.
These are all things that are my nightmares.
But you know, it seems like that's kind of the way you have to go to keep these devices low cost and just be the interface from your programming to the device that you want to use. So.
Precisely, yeah. But we'll get to that in a bit. Folks, what we're going to be doing now is we're going to be showing you how we're going to take what we've already done. We've created this bucket, we've created the solenoid, we've created the relay function, we've created the programming that allows us to trigger that relay with the Arduino. We're going to take all of that along with a real-time clock and actually give you a Growduino. Now, before we get into it, let me say this was deliberately left very, very, very prototype-ish because we've got homework for you. I know we haven't done this for a while. This is actually one of the things we used to do on Coding 101, and we're bringing it over to Know-How. You're going to have all the code. We're going to have the test code. You're going to have this Growduino code that we're going to be testing right now, so you don't have to copy it off the screen. That's going to be downloadable at our show notes. But I've deliberately left the watering function really kind of crap. It's pretty crap. It's actually really, really crap.
Why would you do that?
I have a much better version, but there is a specific problem that you're going to see when we get to the code that I'm pretty sure most of you can figure out, and I'll give you a couple of hints along the way.
Cool. Yeah. All right. A little Easter egg hunt.
A little Easter egg hunt. But before we do that, let's go ahead and take a moment to thank another sponsor of Know-How. Hey, Brian.
What's up?
Notice there's something up with your face.
Yeah, you know, I wake up every morning and all of a sudden there's this luscious beard here.
Is that what it's called?
No, not at all.
No. You know, I tried growing out a luscious beard once, and it just looks horrible on me.
I can't imagine you with a beard at all now.
No, no one can.
No,
it's not good.
But even if you do have a beard, you got to clean it up every once in a while.
You do.
Shave under here.
It gets still scraggly.
Yeah.
Now, whether or not you're like me, totally clean shaven, or like you, who is allowing your face to turn into that.
What was it? Not Bear Grylls, but
Grill Bears.
Grill Bears. Yeah.
Grill Bears.
That's it.
That guy. Yeah. But
Grizzly Adams.
Grizzly Adams. Yes.
You need to find yourself a purveyor of fine shaving instruments. I'm not talking about something that you're going to find behind a locked cabinet at the supermarket, you know, kept away like it's gold bars. I'm not talking about that thing that's going to cost you just so much money over the years because you have to replace blades with expensive blades with expensive blades. I'm talking about a complete shaving experience.
Wait a minute, Padre. We've got a lot of water right here.
No,
I've got a beard.
No,
No, that would be bad.
We're not doing that. We're not doing that. No. Because we don't want to talk about you and your scrabbly, whatever that thing is on your face. We want to talk about Harry's, a supporter of Know-How. Now, Harry's is going to give you a premium shave experience. Now, for decades, one big razor company has relentlessly increased prices and reaped immense profits at the expense of their customers. Harry's is here to change all that with this. Now, this is the kit that I use. This is a beautiful, it's just polished handle, wonderful blades, a great shaving cream experience. This is an all-in-one box for people who want to turn shaving from a chore into something luxurious. Now, if you haven't heard of Harry's before, it was started by two best friends, Jeff and Andy. They were fed up with being overcharged for razors, so they started their own razor company to give people what they deserve, a great shave at a fair price. Harry's shave sets start at just $15, and they include everything that you need for a close, comfortable shave. Weighted ergonomic handles, 5 precision-engineered blades with a lubricating strip and trimmer blades, rich lathering shave gel, and a travel blade cover. One of the things that I've loved about using my Harry's kit is it allows me to enjoy the shaving time. It really does feel good. It's gone from something that I have to do to something that I want to do. And with Harry's, I get that smooth, comfortable glide. I get that nice feeling after the shave where you actually feel like something's better on your skin, on your face. That betterness is Harry's. Harry's is so confident in the quality of their blades that they want you to try their shave set for free. That's right, for nothing. Just cover shipping when you sign up. You heard that right. Start your free trial today at harrys.com and enter the code KNOWHOW at checkout. You'll also receive a post-shave balm for free. That's harrys.com, harrys.com, and use the code KNOWHOW. And we thank Harry's for their support of know-how.
Just a little cleanup mid-show. I always like a sponsor too that has a sense of humor. Like there's lottery numbers on the back of this.
I know.
And then it also says, caution, do not put in your eyes. Rinse if due. Please don't eat. Promise not to sue us. You can stick it up your nose. So, that last part I made up.
No, that's from my Poplars
That's right.
from Futurama.
Poplar.
You know what? Maybe we watched that show a little too much.
No, we haven't watched it enough.
No, all right. Well, folks, okay, let's start talking about shaving and get back to our Growduino. Of course, we've got this. We know what this is already. This is our bucket filled with water, 5 gallons of water, and our solenoid.
And our 3D printed parts to hold it together.
printed parts to hold it together. And again, that's all available at our show notes. This is going to be connecting into our Arduino in just a little bit. But first, let's show you the code. If you go to my screen, Alex, this is almost exactly the same as the code that we just saw, but if you go down to the relay function, you're going to notice that it's changed just a little bit. So when the loop calls the relay, it's going to do, as it did before, it's going to create the holding spots for all the information I'm going to get from my RTC. Second, minute, hour, day of week, day of month, and year. Then it's going to retrieve data from the real-time clock and put it into those holding places. Again, second, minute, hour, day of week, day of month, and year. But now I have to do something with it. In the last example, all I did was I looked at the second, and if the second was odd, it would turn it off. If the second, or turn it on. If the second was even, it would turn it off.
Right.
I need to do something a bit more useful because pulsing the water, not particularly.
I mean, that's basically what we were doing when hitting the button, but it wouldn't be that useful.
No, it wouldn't be that useful, not at all. So what I'm going to do is, if you look here, I'm going to start with the hour. I'm not going to deal with day of week, day of month, or year. Those are kind of not great because I'm going to be doing daily waterings, right? I want my plants to not
grow.
Die. But
that is the ultimate goal, isn't it?
It is the ultimate goal. But there's also plants that will only be watered every other day or every 4 days. And if you're going to do that, then you choose the bit of information that helps you. That would be when you choose the day. Or choose the date.
And then as we get more advanced, you might even hook it into like a water sensor that's in the soil and then say if or that, you know.
Precisely, which is what we're going to be doing in the future. But right now, we just want to turn this on at a specific time. So here we go. Watering, if hour equals watering hour. So this is looking at watering hour and watering minute. And if you look at the top of the program, I set those at the top. So my watering hour is set for 15, which would be 3 o'clock. And my watering minute is set for 2, which would be 3:22. And my watering time is 1, which would be 1 minute. So at 3:22 every day, it will turn on the water for 1 minute.
Okay.
But I have to make that happen. I can't just magically do that. That's what this relay function does. So if the hour, the data it gets back from the RTC, if that hour matches my watering hour, so 3 o'clock, so 1,500 hours. If it's 3 o'clock, then
if
check.
it equals the minutes.
Precisely. So if it's the right hour, check if it's the right minute,
and
which
if
is
it's
22.
the right minute,
then water on. Then call the function water on, and I'm passing it the value of minute.
Okay.
Right? So what's going to happen is...
Minute is 22.
Precisely. So I'm going... Now it's going to call this. So it's calling this function water on, and it's receiving the value of start minute. And the reason why I need this to receive the value of start minute is I know what my watering time is, 1. But this function needs to know what time it started so it can compare it against the real-time clock.
Okay.
Okay, so I'm doing the same thing. This is you're going to do this a lot if you're using an RTC. I'm invoking the real-time clock function. I'm getting the data, and then I am creating an integer called runtime, and I'm going to say runtime equals watering time plus the minute.
Okay.
So in other words, take what I set up above about how long to water it, 1 minute, add that to the minute I start.
Right, and then count down.
Right, so if it starts at 22, it means this value is 23. Okay. Now, while minute is less than runtime, do this. Basically, all it's going to do is it's going to go and turn on the solenoid, and then it's going to check every second. And the second that the minute, so the actual time coming back from the real-time clock, equals runtime, it's going to turn it off.
Okay. And then there was also an else statement that said if you do not receive this time, don't do anything.
Well, I mean, I don't have to. Typically with an if statement, if I don't put an else, it just does nothing. But
Okay.
in this particular case, I do want an else because I want to make sure that the relay is off.
Right.
I don't want to have some weird condition where the relay just turns on and then it just stays on.
Exactly.
This will always be saying it's a positive fail-safe.
Right.
So if something happens, this part of the programming should say, no, turn it off, turn it off, turn it off. It's going to do that every second. Keep turning it off.
That's just good programming.
That's just good programming. And so, this is my function. So what it should do is it should wait until it reaches the time that I set above. It should turn it on for 1 minute, and then it should turn it off.
Okay,
All
so
right.
that's what should happen.
That's what it should do. And if we look at the monitor, this is what we've got. So it's going to give me the time, the date, and then it's going to give me the position of the relay. So relay is off, relay is off, relay is off. That's that positive fail-safe I put in there, right? So it's always reinforcing the relay is not currently triggered. What we need to do, though, is we need to connect the relay
and
to the
make
Arduino.
sure that it continues to be off. Yeah.
Right. So let's go ahead and do this.
Oh, you want me to do this?
Well, no,
Plug in the wires?
These are. It's electricity, Brian.
I know.
Remember, I was told I'm not supposed to do anything that might kill you.
What?
I know, right?
I thought that was like in the contract that you were supposed to put my life in danger.
I don't understand these people.
What's the
sometimes.
thrill of watching Know-How if you don't see,
If you don't
see a
kill
co-host
Brian.
almost get killed? Yeah.
Yeah. Okay. So let's do this. We're gonna go ground and remove that. Okay. So now instead of connected to the onboard relay, it's now connected to this relay.
Right.
And I'm gonna give this relay 12 volts.
A separate power, yeah.
On separate power so that it has the ability to turn on the solenoid. So this is now a live circuit. If this relay turns on, it should. There we go. Okay. I set it for positive. And there we go.
Okay.
Toot toot. And then when I disconnect power, it should. Good. All right.
Cool.
So we know it works. Now let's go ahead and set our condition.
Okay.
So what time is it? It's 11:52. Actually, we could probably just check this. It's 11:51. So what I'm going to do is I'm going to set the on time for, say, 11:52.
You better hurry. You've got less than 30 seconds.
52 with a watering time of 1. So let's upload that. Hurry up. Upload. Hurry. Upload.
The clock is ticking. So this should turn it off, or?
Hold on. We got to turn on the serial monitor. Okay, you know what? I actually wired it backwards. I just realized that. Hold on. Let me do that.
No problem. Just cut the red wire.
Yeah, okay, so in soldering this together, I may have accidentally connected the lead to the other side of the relay.
You sure that's what happened? It didn't look like you had uploaded it in time.
Well, no, watch. Hold on.
Okay.
Wait. Okay, no, it froze. Yeah, let's do that again.
Oh, live demos.
Live demos. Why do you hurt me so much? Yeah, I think you're right. I think I didn't make it.
Yeah, I think you set it for like 52 or 52 seconds, and I think it went by.
Oh, wait, no, because I have it set for the wrong hour.
Oh, 3. Yep.
So, wait, what time is it on that clock now?
11:54 at the moment.
52, so 53, so let's make it 54.
Yeah.
You know, I probably should have put some seconds in here. That probably would have helped it.
Oh, yeah, that would have helped a lot.
Okay, here we go.
Uploading. Okay.
Okay, but the problem is that I still did reverse this. So when I do this, it's actually going to turn the water on, and then when it hits 54, it's going to turn the water off.
So you've got it reversed.
This is not a software problem. It's physically I reversed this.
Well, we get the idea though.
Soldered to the wrong. That was just kind of stupid. I'm going to get really quick. I'm going to let this get to 11:53 and 55 seconds. I'm going to plug this back in, and it should turn the water off. Hold on. Okay, wait. Go back to my screen. Okay, and hold on. 1, 2, 3, 1.
3.
Okay, so we got water on.
55, 56, 57, 58, 59. And it's off. So yeah, it worked.
It works.
in reverse.
If you solder the right way.
So you're going to be not watering your plants for 1 minute and be watering your plants for the next 24 hours.
Well, so, I mean, I actually can fix this in software.
So
I would just reverse the bit.
Will it turn back on after a minute?
Yeah. So, okay, let's let this run. So, yeah, all this is doing is it's checking once a second to see if the condition is met. If the condition is met, it will leave the relay in the on position, which unfortunately I soldered backwards. But normally...
So tell me, how did you kill your plants previously?
Okay, previously it was a software issue. This time it's a hardware issue. And see, it was, of course, it's after I black taped everything together. That's
oh yeah, you can't go back after that black tape.
Oh gosh. Wait, hold on. 50. Okay, 51, 52, 53. Okay, and it should turn back on when it actually says it's off because my coding is bad.
And relay is on.
There we go.
And it's back on. It's okay, we can fix this.
Yeah. All right.
No problem. I'll just hang out here for the next few hours. And
So
wait.
you're a new Arduino component.
That's right.
All right.
But I'm very unreliable.
I'll pull this. Okay, so this does work. Again, I wish I had tested this bucket before we came into the studio because I would have realized I had hooked up.
What's the fun in that?
Actually, here, look down. In the code, all I'd have to do is in the watering hour, this digital write, I could just switch that. Right? Because that, hold on, where is it?
And I guess you'd want to change it. You could change so it says instead of relay is on, change it to relay is off.
Precisely. So right here, what I would do is instead of sending 1, I would send a 0.
Yeah,
And
that's
it would flip it the other way.
Yeah.
But I actually did solder it the wrong way. So, I mean, I don't want to change the software to fix my boneheaded hardware screw up.
That's what I would do.
So I'll fix the hardware. Now, here's the thing, though, Brian, and this is the homework that we're going to be giving to all of our know-it-alls. This is actually a horrible, horrible function. If you look back at this,
what you see here should disgust you.
It should disgust you because, yes, you can do it this way. Hour equals watering hour, minute equals watering minute, water on minutes. You've seen it. It does work, even though my hardware's wrong. It does work. Here's the issue. What happens if I set for 5 minutes of watering, right? But then I say I start the watering at 3:56.
Okay.
The problem is it's going to get to 3:59 and then the hour is going to change to 4. And because the condition isn't met on watering hour, it's going to shut it off a minute early.
Oh,
right? Because it doesn't compensate for the fact that minutes will roll over to 60 and then go back to 0.
Oh, good point.
And then the hour will change, which will screw up the condition. So there is a way. There is a way for you to error check that. Now, you could do a bunch of if and else. You could do case statements to find out whether or not you're looping around the hour. Or, and here's the hint, you could not look at the day in terms of hours and minutes and seconds. You could look at the entire day in terms of seconds because an hour is 60 minutes.
Right.
And so you could just get 24 sets of 60.
Just break it down into the one category of seconds.
But that would also mean that for the variables that you set at the time, the watering time and how long you run, you'd have to convert that the same way. So you'd have to write the function so that you have all of the minutes in the day and it knows only to run it between this minute and this minute. It actually simplifies it on the turning on side. It actually but it makes it more complex on the actual figuring out when to start time.
Yeah, and reading it. And you're like, what does it mean to turn on at 4,000 minutes?
Precisely. But it's not as simple as it sounds because you're going to have to do some data type conversions. Remember I told you that this actually gives me data. The real-time clock gives me data in bytes. It's in characters. It's not an integer, so if you're planning to do math on it, you may have to be a little tricky. But I'm going to leave that up to you. I'm going to present a completed solution in a couple of weeks. We've actually got a version of this that, let me do this. I think you're going to like this, Brian, because what we're going to start doing with our projects is... Actually, let me zoom in here.
Look at this.
As you can tell, so this is the exact same thing, but I now have the ability to set my time and my watering date on the control. So I don't need to have this connected to a laptop to set my date and time.
That's
I can just,
cool.
Yeah, right?
You got a little UI there.
Exactly.
That's awesome.
So I've got my real-time clock, I've got my Arduino. This is where I hook up to the relays, but I've also got an interface, 4 buttons that are going to allow me to set the time, and I can also set the watering time. So there's going to be a little menu system. The code for this is a lot bigger than the code for our other
Oh, I
programs.
bet.
Yeah.
But aren't you clever? Look at
Yeah,
that.
it's
You
kinda
could
cute.
3D print a little box with
Yeah.
buttons on it and stuff, and make it an enclosure.
Precisely. And the cool thing about that entire project altogether, including the RTC, is still under $10.
That's cool.
And here's the other cool thing about it, and this is the other reason why I wanted to show you. Remember how I told you how I2C is cool because it allows you to connect multiple devices?
Yeah.
Both of these are on the same I2C bus.
Ah, okay, okay.
So they have different addresses, but you can see it right here. They're hooked up to the same pins.
Right.
So same two wires, but the Arduino, because it knows which address is which device,
It's passing through
can
the
individually address each one.
That is neat.
There we go. So that's going to be the next iteration. So this is something for you to take home and play with over the next couple of weeks. We're going to be taking a break from the Growduino project because we do have some other fun projects we want to throw in here. But when we come back, it's going to be a finished version with this in a 3D printed case, and then we're going to start adding sensors.
Very cool. I like this. I like this where this is going.
Yeah. Folks, we know that this was a lot of information, and we know that there was a lot of code. We don't expect you to copy it down from the screen. There was
You should
someone-
just write it down as you go along,
Yeah,
right?
Yeah.
No problem.
One of the people in the chat room was like, am I supposed to see that? Well, no. You don't have to. All you do is go to our show page. You can download the code for both of the demos, as well as get links to all of the pieces that we've shown you. And Brian, where do they find that?
You can find them at twit.tv/KH. And like Padre said, you're going to want to go there to find links for all the parts that we used and definitely for the code, unless you really want to write it down as you watch, or if you're an audio listener, good luck with that. But otherwise, yeah, we've done multiple episodes, so you want to go back and download those, or if you've missed an episode, be sure to subscribe.
Yeah. And also don't forget that you're going to find us on the socials. That's all over the internet.
That's what the kids call it,
Yeah,
right?
those cool kids. Find us on Google+. Just go to Google+, look for Know How. There's a very short approval process for you to get in the group. That's just to keep out the spam accounts. But once you're in, you get access to almost 11,000 Kitas. That's our know-it-alls. These are people at all stages of their maker DIY journey, from experts to beginners. If you're a beginner, come in and ask questions. If you're an expert, come in and answer questions. And make sure to ask us questions and show us your projects so we can use it on the next feedback episode of Know How. Don't forget, just go to Google+ and look for Know How.
That's right. But the other socials?
The socials, the things, all the social-ish stuff.
Well, the other socials,
Yeah.
with the little bird, we're on that. And if you want to find out what projects we're working on, or you want to contact us directly, or send me a Corgi GIF, which I always
We love
appreciate
Corgi
those.
GIFs.
You can do that on Twitter. I am at cranky_hippo.
And I am at Padre SJ, and our fantastic producer, he's a good guy.
Producer?
He's
Is
director.
he a
No,
producer,
he's
director?
director.
Actor, singer.
That's yes, exactly.
Alan
He's so
Smith.
talented.
Alan Smith. You can find him at twitter.com/ANELF3. That's for Alan Smith.
Alex Smithens. Yeah.
I'm on the cyber.
Cyber. Until next time, I am Father Robert Balaser.
And I'm Brian Burnett.
And now that you know how,
Growduino it. Part 3. Now let's start unplugging things and see if we can figure out where to put them again.